Welcome to Don's Manufactory. It's time for another go-round with Betsy, getting some parts. I just got them in. Let's get a look at them. So, first thing out of the chute, shims, bolts for bolting everything up. Okay, I can tell you the first thing I don't like about these is they're not shouldered bolts or shouldered nuts. Okay. Oh, they came assembled. From the pictures, I thought I was going to have to assemble these. So, these are the stock replacement units. There's got to be a Zerk fitting somewhere for the ball joint, right? What the heck? Like you're never supposed to grease these ball joints? That can't be right. Dropping stuff. Well, I hope that's not the harbinger of how the day will go. Okay, well, these are the same instructions I saw online. Yeah, instructions for standard Shelby drop. Okay. Which is kind of funny because online, when you're watching their videos, they're talking about not doing a 1-inch drop, but doing an 1 3/8 I can tell you that one of my first concerns about this design was whether there would be any torsional flexing, because that would pop the nuts loose on the adjustments. But if one is careful about making sure the spherical joints are centered, then any torsional flex will just rotate the spherical joint and not break the nuts loose. So I'm not worried about that anymore. Judging by the spherical joints here, there will be a limit to how much difference you can make. That being said, but that's a lot. The original design was that the arm was constant, so the critical adjustment here was to get your caster at 0, and once you had the caster at 0 and your camber at 0, then just by default, because of the design of the control arm, the attachment points that the whole thing pivots on have to be in proper relationship to the lower control arm. So that becomes the challenge here now, is more variables have been given to me here, as in, yes, I can adjust caster and camber very easily using these turnbuckles, but before I do that, what I'm going to have to do is ensure that I get these attachment points, pivot points, in the proper place when I bolt this up, so that relationship of these attachment points to the lower control arm and inner attachment point, that relationship is correct. Because then after that, I can adjust whatever caster I want, but the movement of the arm will still be in proper relationship to the lower control arm. How in the hell am I supposed to grease this thing? I don't understand. I don't know. Anyway, what I'm going to have to do is get this perfectly square. So that sort of becomes my dilemma, is I need these pivot points to be in proper relationship. And the only way to do that is to square this up, make it the same length as the stock one, and set it for 0 caster. So I'll be using some of my shims, I suspect, especially on the driver's side, in order to get that squared up. On the passenger side, all of this stuff I've been doing has pretty much had the same amount of shim stack on both front and back, but on the driver's side that's not been true. Okay, so now you know what I'm up against. Makes it, see, there's no frame of reference, and they don't give you any measurements in here. What it is, I kind of think they expect you to just bolt it in, adjust it till it works. But if you did that, then your attachment points could have any number of deviations. You could end up with a control arm which is longer on one side of the car than the other side of the car. That doesn't make any sense either, because then the arcs would be different, and so under load and articulation, the car would handle differently left to right. So it's really important that these attachment points end up exactly where they belong. Okay, so I'll have to come up with a methodology for that. I'm confused. Right here in the instructions, they're showing a cutaway and a Zerk fitting going into the ball joint. This cap has no cutaway. Okay, so there'll be a slight pause while I call them on the phone and say, okay guys, what's going on? I called Total Control Products. They said that I should rough the arm in at 9.5 inches from the ball joint center line to the pivot point center line. So that is where it is right now. Both of these are set up at 9.5 inches. And I also measured from here back to here on both sides in order to make sure that the ball joint is in the center between the two pivot points. So now I have a square swing arm, control arm, that can go on either left or right. So it's very much like the stock one. The first thing is I unbolted this ball joint here so that I could get out my tools that I used when I was setting up my control arms when I was redoing them. And here, let me just rough measure this for you. Okay, we put that right on there. Let's put it all the way to one side like so. Okay. Now let's zero that. Bing. And now I'm going to go all the way over here. 58 degrees. Okay, so that's all the sweep that this ball joint that they have has. This arm has no opening for a Zerk fitting, and this ball joint has no provision for a Zerk fitting. So apparently you're supposed to just put it together, and when it's time to grease it, you're supposed to take it apart and try to get grease in through this way, which doesn't work, by the way. Been there, done that. I just tried to see if I could grease it, and it's so tight that it won't go in there. Maybe after it's worn it would, but that's not what I want to do. A year from now, when I need to grease the ball joints, I can't grease them. I'm just supposed to wait for them to fail and then replace them with a decent ball joint. I looked these up. They are Metrix Premium 0723. And if you looked up that part number online, it comes up as an $18. That's retail, $18. It's just a cheap ball joint. One of the cheapest ones you can buy. So I'm just a little weirded out there as to how long these will last. I mean, that's a lot of money. Okay, so next problem. You know, I just measured this stuff up like this to make it square, and to have 9.5 inches from the center of the ball joint to the center of the pivot point. they told me on the phone 9.4 to 9.7, and that's probably seems like if you're doing a Shelby drop, that 9.7 would be the better choice because you're doing the hypotenuse and it has to be longer. This is the way it goes when you deviate from stock. You have to go through the entire design phase. I have to guarantee that the ball joint will not run out of travel with this flat architecture here. This ball joint will survive in my suspension and the way I drive the car. And I won't know that until I go through the whole design phase with it, exactly as I did when I was building my own control arms. Okay, so I haven't even started tearing the car apart yet. It's sitting here with the hood up, just waiting patiently for me to get busy on it. But until I satisfied myself that I was on to something, then I wasn't going to commit to tearing the car apart. Here's my solution to the greasing problems. I ended up taking the ball joint out, and I drilled a hole right in the top of the ball joint, ran a countersink into it, and then I drilled this cup and tapped it for a zerk. Then I had to make a gasket so that there'd be a seal between the arm and the ball joint, so the grease wouldn't come out the wrong spot. And indeed, it took a little bit of grease because I had to fill that entire cavity, but it did fill the cavity and force grease into the ball joint, which came out the lubricating grooves in the ball socket. So I can now grease this just like a regular ball joint, like I should have been able to do from the beginning. Okay, so these are now prepped. Have to transfer the spring perches over. I'm using my roller ones, of course. I also had to transfer these retainers, the seal retainers, off of my old ball joints because they didn't come with them. But that's what it's supposed to look like when you're all done. If you don't have this retainer on here, you're more apt to get water into your ball joint. Now, I tell you that when I look at the engineering of this whole thing, it makes me think that they don't expect me to drive this car in the rain. That I'm doing this for a track car that's only going to see track days, which are going to be sunny days, or I'm only going to drive it to Cars and Coffee, and it's not going to get wet or screwed up, so they don't have to build a part that's going to last 100,000 miles. But it would have been nice to have, just a small little Zerk, like right there. Not even the ones that you hook a thing onto, but the one you use a needle on that still has the check valve in it, so that you can just put it over the top of it and get some grease in the thing. I don't know. If it were me, I'd engineer it different. This ball joint only has 58 degrees of travel, as opposed to the factory ball joint, which has 70. Basically what happens is when the suspension is all the way extended, it's hanging off the ball joint right here. So if that ever happens while you're driving, for any reason, there's a good chance this ball joint will just break. So the thing I have to make sure, and I haven't checked this yet, and that is the shocks have to stop before this ball joint reaches the end of its travel. It was much nicer on my own. I might as well show you. On my own modified control arms, you notice there is an angle here. If you look at it, the ball joint sits at an angle. It's not on a straight line from there. It's about 12 degrees. And what that did was, with the 70 degrees of travel, that meant I had 10 degrees left at the top of the travel, and I had 12 degrees left at the bottom of the travel. And that's with this swinging arm going all the way down to hitting the frame. So at no point ever would this ball joint be at the end of its travel. And you'll notice, just by looking at it here, that other ball joint just has a round hole But look how they cut away the two sides of this ball joint to give it extra travel. And that's why, you know, it goes a long frickin' ways. And that's why when it's all the way down, you don't run out of travel. Look at how much angle that has on it. So this arm can be way down like this and still not be at the end of its travel. You know, it just makes things difficult. Like, let's say I have to change shocks. So I jack up the car and I undo the shocks and everything. Well, as soon as the shock top is undone and the top support, this thing here, is removed, well, then the shock is going to go down in the spring, and the ball joint, this ball joint here, will swing all the way out and hit it, you know, right at itself, run out of travel, and then it has to hold the strength of the spring pushing down on the suspension, plus the weight of the wheel and whatever else. It's actually kind of a hazardous situation. You could easily fatigue this ball joint during your regular maintenance, like off-season maintenance. You could end up screwing up this ball joint. Okay, so this one is ready to go into the car. Got shims in there. I have it roughed in as close as I can get it before using these for adjusting. So this side is at 0.7 positive caster, 0.7 negative camber. The other side is 0.5 negative camber, 0.5 positive caster. So they're within 2/10, and that's as close as my angle finders are. Anyway, thanks for watching, and I'll catch you later. Cut.